Look around you. Concrete is everywhere. The foundations of your home, the office buildings downtown, the roads you drive on. It's literally the foundation of modern civilization. But what if I told you that this miracle material, the second most consumed substance on Earth after water, is hiding an environmental secret? A carbon footprint that dwarfs the entire aviation industry, yet receives just a fraction of the attention. The numbers are staggering. Concrete production is responsible for 8% of global carbon emissions. That's more than 3 times the impact of all flights worldwide. If the cement industry were a country, it would rank as the 3rd largest carbon emitter behind only China and the United States. Why? Because making cement, the key binding ingredient in concrete, requires heating limestone to extreme temperatures, releasing enormous amounts of CO2 in the process. For every ton of cement produced, nearly a ton of carbon dioxide is released into our atmosphere. Let's follow the journey of the concrete in just one commercial building. It begins with limestone extraction, massive quarries that scar landscapes and disrupt ecosystems. This limestone travels to cement plants where it's heated to 1,450 degrees, typically using fossil fuels. The energy requirements are astronomical. Once the cement is produced, it's mixed with water, sand, and aggregates to form concrete, then transported by trucks to construction sites. Every step in this process adds to its carbon footprint, a footprint that's largely invisible to us, despite being literally set in stone all around us. What's particularly ironic is that modern concrete actually underperforms compared to its historical counterparts. The Romans built the Parthenon nearly 2,000 years ago with a concrete dome that still stands today. Meanwhile, many modern concrete structures begin deteriorating after 50 to 100 years. Roman concrete incorporated volcanic ash that made it more durable and actually strengthened over time through a process of mineralization. Yet, we're optimized for quick-setting, low initial cost concrete rather than longevity, multiplying our environmental impact through constant demolition and rebuilding. So why haven't we addressed this crisis? Follow the money. The concrete industry has invested heavily in lobbying efforts to prevent stricter emissions regulations. With profit margins already tight, many industry players resist change that might increase short-term costs, even if it would benefit humanity in the long run. But there's another factor at play. Concrete's carbon problem has remained largely invisible to the public. Concrete's emissions occur primarily during manufacturing, out of sight and out of mind for most consumers. Yet there's hope on the horizon. In Oslo, Norway, zero-emission construction sites are proving that building with significantly reduced carbon footprints is possible today. They're using electric machinery, alternative materials, and careful carbon accounting to revolutionize how we build. Meanwhile, researchers at Washington State University have developed a concrete that actually absorbs more carbon than it emits. By replacing a third of cement with biochar, a form of charcoal made from agricultural waste, they've created carbon-negative concrete. As Professor Jianming Shi puts it, with this, we should be able to help get to carbon neutrality of the built environment. Companies like Pable are capturing carbon directly from the atmosphere and combining it with ground rock to create materials that can reduce concrete's carbon footprint by up to 70%. Another company, Carbon Cure, injects CO2 directly into fresh concrete, where it mineralizes and becomes permanently bound, reducing emissions by 3 to 5%. Policy is finally starting to catch up. New Jersey recently became the first US state to pass a law promoting low-carbon concrete through business tax credits. The US federal Buy Clean initiative has designated over $2 billion for the procurement of lower carbon construction materials for federal projects. But these are just the first steps. To truly solve concrete's carbon crisis, we need comprehensive building code updates, carbon pricing that reflects the true environmental cost, and significant investment in scaling alternative technologies. The path forward isn't about abandoning concrete. It's too useful and too ingrained in our building practices for that. Instead, we need to transform how concrete is made and used. The solutions exist. From ancient wisdom about adding volcanic ash to cutting-edge carbon capture technology, we have the knowledge to break our concrete addiction, or at least make it far less destructive. The construction industry's hidden carbon crisis doesn't have to remain hidden. And by bringing it into the light, we take the first crucial step towards solving it. The choice is ours. And unlike concrete, that choice doesn't have to be set in stone.